Hello everyone. Today we want to find the solution, the result of this expression, I to the power of I. But I is the imaginary number, and by definition I is square root of -1, or I squared is -1. Both definitions are same. For as a start point, we have to consider a helpful equation. We can prove in the another videos, but for now just accept this formula. -1 is always equals to e to the power of I pi. E is the Euler constant and pi is the pi number. You know about the pi from the circle. Euler number is approximately 2.718, and other numbers but it's approximately, and pi is approximately is 3.141 and other numbers. We can use this form to find the solution of this expression. For now, we start from this equation here. -1 is equals to e to the power of I pi. If we square root of the both sides or get raised to the power of 1/2, because you know a square root of any variable equals to a to the power of 1/2. It's the aspect for the square roots. Definition of the square roots. Now to the both sides we have a square root of -1 equals to a square root of I times pi. From the definition of imaginary number here, a square root of -1 is I equals to, and from the definition of a square root here, we can get raised instead of the radical form I pi gets raised to 1/2. If a to the power of m gets raised to the another power of n, it equals to a to the power of m dot n times n. We have to multiply the powers. Now, I can rewrite this answer like this. I equals to e to the power of I pi times 1/2. That returns to I equals to e to the power of I pi over 2. This is the definition of I in the other language, in language of Euler constant. But we want to find the solution of I to the power of I. So, I to the power of I, what is the number? If we use from this form, new form, and get raised to the both sides of the equation to I, then I to the power of I, as we found here, equals to e get raised to e to the power of I pi over 2 gets raised to I. And you know from here, if we get raised the power of a to the power of m to the another power, we have to multiply the powers like that. So I to the power of I equals to e to the I pi over 2 times I, and this equals to e to the power of I times I is I squared times p over 2. But we know from definition I squared is minus 1, so we can rewrite it like e to the power of minus p over 2. So we find eventually I to the power of I is e to the minus pi over 2. This is the answer, but we can find the exact value in the numbers of this expression. But we have to change something here. I to the power of I is equals to, we can write it e to the power of minus pi times 1 over 2. We can write it like that. And when the powers of multiply by this definition but reverse is like e to the power of minus pi to the power of 1 over 2. And 1 over 2 is a square root. So e to the power of minus pi. And a to the power of minus b equals to 1 over a to the power of plus b. Minus in the power is the reverse of the denominator powers. So I to the power of I equals to a square root of 1 over e to the power of pi. We can break down the square root, 1 the square root and the numerator, and e to the power of pi. A square root of 1 is 1 over a square root of e to the power of pi. But we have the approximately numbers of Euler constant and pi. If we find by calculator, we need to use the calculator here. It's not point to find mentally the numbers we can use. We just find the expression for I to the power of I. E to the power of pi is, again, approximately 2.718 to the power of 3.141, and this will be approximately 23.141. So I to the power of I is equals to 1 over a square root of 23.141. Again, by using calculator, you can find the number of these terms. This expression is approximately 0.21. So by numbers, it's the approximate number is 0.21. This is the number, and that is the expression. We can prove this the first and basic formula in another videos. If you like these videos, you can visit my channel, subscribe, and watch more videos. I upload 2 times or 3 times per week. Thank you for your attention.